What's up, guys? How's it going? We're working on Theorem 7.2 today, Polygon Exterior Angles Theorem. Say that 10 times fast, I dare you. So here's the deal. Last time we were here talking about interior angles, right? And those were all these angles inside a polygon. So depending on the number of sides of the polygon, this polygon we're looking at here has 5 sides, so there are 5 interior angles. And now we're going to go ahead and take a look at exterior angles. So again, these exterior angles are labeled here. And again, there's going to be the same number of exterior angles as there are sides. So in this case, again, 5 exterior angles. Now, that Theorem 7.1 had to do with the number of sides of the polygon. What's interesting about Theorem 7.2 is it doesn't matter how many sides are in the polygon. It's not going to change what the exterior angles sum up to. So let's take a look at what I mean by that. Let's draw a polygon that we all know really well, the square. Square doesn't get enough love. What's up, square? So here's how we're going to do it. We're going to draw the exterior angles so we can see the exterior angles for the square. So I'm just going to extend these lines out, try to make them relatively straight. Yeah, close enough. And close enough. So now when we're looking at the square and its exterior angles, we can see that all of the exterior angles, I'll do these in green here, are going to be 90 degrees for the square. Now, if we sum those up, there's 4 exterior angles because there's 4 sides to a square. And so we have 90 plus 90 plus 90 plus 90 4 times. So 90 times 4, and that equals 360 degrees. And what's really interesting about this theorem is this piece, this 360 degrees, is always going to hold true. It's always going to be 360 degrees, no matter how many sides. So this 5-sided polygon over here is also going to sum to 360 degrees if we sum those exterior angles. Okay, so let's take a look at how this could possibly be. Slide over here. So if we look at, this is another 5-sided polygon, and if we look at all these exterior angles on here, we have the orange and the red and the yellow and purple and green angles. If we took those angles separately and combined them all together, we would be left with this nice, lovely circle. Right? So if we drew a circle around this whole thing, let's see if we can draw a circle in this program. Whoa, it's kind of a circle. Okay, if we drew a circle there, those exterior angles are going to make up all the angle measures of a circle. And a circle always has the angles 360 degrees, right? If you jump up and spin around, you've done a 360, right? You've completed one circle, one revolution. So that's always going to hold true regardless how many sides are in our polygon. So let's write down what that theorem's going to look like. So no matter how many angles we have, so let's say measure of angle 1 plus measure angle 2 plus measure angle 3, so on and so on and so on. This could go on for as many exterior angles as we have. So we're going to say plus measure angle n. A lot of times we'll throw like a dot, dot, dot in there. So however many goes up till n, till the number of sides in your polygon you're dealing with, is always going to be equal to 360 degrees. So that is the theorem right there. Let's circle that thing in bright yellow. This is our Theorem 7.2 Polygon Exterior Angles Theorem. So if we take these exterior angles, these outside angles, and add them up for any size polygon, they will always sum to 360 degrees. So let's take a quick look at an example problem. So here we got another 5-sided polygon, and we are going to sum up those exterior angles. Let's choose a new color. Let's try blue out. So I'm going to start here at y. So notice we have 2 variable angles that we're looking to solve for. So this problem is going to ask us to solve for y. Okay, we're trying to figure out what y is. So we're just going to start up here at this top y and work our way around clockwise. So y degrees, and it doesn't matter which way you work around. I just want to make sure I add up all of the angles. So y degrees plus 61 degrees plus 2y degrees plus 35 degrees. Sorry, I'm not the fastest at drawing on paint here, but I'm getting better. Plus, that's a plus sign, 50 degrees plus 64 degrees. And we know that that is definitely 100% going to equal 360 degrees. Right? That is our polygon exterior angles theorem. It says no matter how many sides we have, those exterior angles will always add to 360 degrees. So at this point, all we have to do is combine our like terms. So we have 1y here, we have 2y's here. So we can combine those and give ourselves 3y degrees. And then we can, of course, combine our other like terms, which are just our numbered angles here, and add all of those up. And I will save us some time and add them up quickly here for us. So let's see, 96 plus 50 is 146 plus 64 is 210 degrees. You can pause and check yourself on your calculator if you'd like to do that. And that's going to still be equal to 360 degrees. Next, we're going to subtract 210 degrees from either side. So now we're just working through our basic algebra steps to get y isolated. So we're left with 3y equals 150 degrees. And finally, we're going to divide both sides by 3. So we are going to be left with y equals 50 degrees. So there we just used the polygon exterior angles theorem to solve for an unknown angle y. There we go. I hope that made sense. Please feel free to go back and watch the video at your own pace, pause it, make sure you understand every step of the way, and you should be all set. Thanks for watching.